camera, man.
Oh yeah, forgot about that.
Okay, so these are gonna do 1A and 1B.
Mark will do 2.
Mark's doing number 2.
I'll do 3.
Max is doing 3. Who wants to do 4? Max, calling somebody to do 4. People will do 4.
Who?
Okay.
Okay.
So this is a spiral warm-up. This is a little bit of everything that we've done so far. Next 6 weeks you have your first, even though the CBA isn't going to the district for like Scantrons and stuff, we're still going to give it to you. And it is cumulative. So it covers chapters 1, 2, 3, and 4. Okay, so that's why we're starting to spiral some of that older stuff in, because you still are responsible for retaining that information.
So it goes over everything you learned
so far. And that'll be the first test of next 6 weeks.
Wait, what is this? Over everything?
So far. So that's why we are doing these spiral warm-ups. Because you're not supposed to just learn something and forget it.
But is it going to be like the really hard questions, or is it going to be some of the easier ones?
It's going to be multiple choice.
the whole thing?
Almost.
Alright, that means I can at least get...
It's like your old CBAs that you took last year in geometry. It's like that. Sweetness, so, he has f inverse of x equals 1/2 x minus 4.5 because he distributed it. If you have 1/2 parentheses x minus 9, that's the same thing. Or if you have x minus 9 over 2, it's all the same thing. Okay? Part B has 16x squared plus 144x plus 314. Any questions on 1A or 1B? Okay, Mark's gonna come do 2. There's gonna be the cup to the left. You can finish here if you want.
That's fine.
Okay, you've made one mistake. What do you think it is?
Is it right 10? Or...
Well, that's where your mistake is.
Okay.
So what did you mess up?
Is it less?
Very good. You have to factor out that 2, remember? X has to be by itself, so factor out the 2 inside.
Okay.
So you still have absolute value 2, very good. And then parentheses. So how far right are you really going?
5.
Very good.
Wait. Yeah.
Okay, stay up there. 2 mistakes. What's one of them? Axis of symmetry is always a line, not a point. So where is your axis of symmetry?
It's on the X.
X equals what?
5.
5. So make that change. Okay, one more mistake. What do we have? Your range. What's the matter with his? You need to flip it because you reflected it over the x-axis.
Okay.
Therefore, your range flips too.
Okay.
There you go. Awesome. Max, let's go.
Oh gosh. Go Max.
Come on, Max, go.
Stop that.
I use a Okay.
Mhm.
Let's see. So you have to add this to there.
Okay, awesome. For most of you, you probably isolated first before you set up your two different equations. So Max, in the future, make sure you get your absolute value by itself before you set up your two equations. So you should have divided by -3 first, and then set up your two equations. In this case, it worked out though. Number 4. Oh yeah, let's go.
Oh yeah.
Claire, you're gonna have to go, otherwise you won't finish. And she has a test for you over there. Make sure, I don't know if you're gonna remember it, on the calculator part, just ask her what you're supposed to change. So that she won't forget to tell you. Miss Heckes. Where Miss Gover was. Bye, good luck. Do great.
Oh.
Awesome. 9, 4, and 2, -3 should be your two solutions. Any questions on the linear quadratic? No questions? Awesome. Alright, so we're going to go through Meet Perry just real quick, so we can point out some of the things before we fill out our summary sheet. Alright, let's look at the parent function. Okay, so your parent function points that you're most commonly going to use are 0, 0, 1, 1, 2, 4, 3, 9, -1, 1, -2, 4, -3, 9. And the reason being is that those are the 7 points that are most commonly fit on a coordinate grid that you're provided. So it's very similar to absolute value, except for you don't just drop the bars and make it positive, okay? This time we actually have a parabola and a U-shaped graph. Okay, so your symmetry still applies, okay, at your vertex and your x-coordinate. Okay, so x equals 0 is our axis of symmetry for our parent function. Our vertex is at 0, 0. Our domain is all real numbers. Range is y is greater than or equal to 0. And then our minimum is at 0. So when y is 0, that is our minimum. If it's reflected, then you have a maximum. Okay, so if it's reflected over your x-axis, your vertex will represent the max. Numbers 1 and 2. Okay, this is where a lot of people make mistakes, and I believe we had a question like that on our last test, where you had to square a negative. Right here, if it's not in parentheses, okay, so say this was -2 squared, you're squaring 2 first and then attaching the negative. So all of your values should be negative. Okay, a lot of people say -2 times -2 and end up with positive. Okay, the only time you do that is if it's in parentheses. Okay, so a -2 squared that's in parentheses will give you all positive values. But if it is not in parentheses, you're attaching that negative after you apply the exponent. Okay? So all of these should have been negative, all of these are positive. Okay? Same thing applies though, if it's outside of the parentheses, it's going to be a reflection over the x-axis. If it's inside the parentheses, it's a reflection over the y-axis. Okay? So, upside down, and then across the y-axis, it doesn't appear that there's a change because we didn't move left or right or do anything to our vertex. So, it looks the same as your parent function in this case. Any questions on the reflection part? Okay, so really pay attention to those parentheses and whether you're tacking on that negative at the beginning or at the end. Let's see. Okay, number 3 was a vertical shift up 3. All you did was add 3 to all of those y values. Your axis of symmetry stayed the same, your range stayed the same. The only thing that changed was your domain stayed the same, your range changed because your vertex changed. Okay, so we shifted up 3 units, therefore our range shifted up 3 units as well. 5, we moved to the left 3. So again, just taking all your x values and moving left 3. So this time our axis of symmetry changed because the x-coordinate of our vertex changed and our range stays the same. Okay, domain is always going to be all real numbers. Okay, so same thing like absolute value, our domain is always all real numbers. We jumped down to number 7, 2x squared. So again, a vertical stretch by 2. We're outside of our parentheses. We are a whole number. Okay, our whole numbers always make things more narrow, and then our fractions always make things wider. Okay, so whether it is a horizontal stretch or vertical compression, it's going to go wider. Vertical stretch and horizontal compression is going to make it narrower. So in this case, everything stayed the same, so we just stretched our parent function. I want you to plot your parent function, if you can, in a different color on your graph. Okay, if you plot your parent function in a different color on your graph, you get something like so. Ooh. Okay, so notice how your new function, 2x squared, is narrower. Okay, let's look at our vertical change from our parent function to our new function. Okay, how many units up did we go from 1, 1 to 2, 4? How many units is this? So how did you go from 1, 1 to 2, 4? How many units did you have to go up? 3. How many units did you have to go up from 0, 0 to 1, 1? How many units did you have to go up from 2, 4 to 3, 9? 5. Okay, so notice how we went from 1, 3, and 5 to now if you look at your new function, how many units did you go up from 0, 0 to 2, 1? Or 1, 2, sorry. 0, 0 to 1, 2, you went up how many units? 2. How many units did you go up from 1, 2 to 2, where are we? 2, 8? 1, 2 to 2, 8, how many units did you go up? 6. So notice how 1 times 2 is 2, 3 times 2 is 6. 5 times 2 would be 10, and it would be way up here. So that is where that vertical stretch comes from. Okay, so you're looking at your parent function in comparison to your new function, and you're looking at that difference in your vertical values. Okay, so that is where that number comes from. Okay, if you turn the page. Okay, you have your vertical compression by 1/2. Vertical compression is the same as your horizontal stretch. Okay, and this time your x values are, your vertical values are changing, so we're decreasing by half. So I kind of did that same thing here. Our new point is at 2.2, and our parent function was at 2.4. So see how those x values are decreasing. Our parent function was at 3.9, and now we're at 3.4.5. So we divided all of those y values by 2. Number 9 and 10 is our horizontal compression by half. Okay, it looks like the same thing as your vertical stretch by 4, because algebraically 2x squared, 2 squared is 4, x squared is x squared, so it equals 4x squared, and that looks like a vertical stretch. They're equivalent. And then number 10, same thing, this looks like a vertical stretch by 1/4, vertical compression by 1/4, because 1/2 x squared algebraically is the same thing as 1/4 x squared. Anytime you have a fraction, like I said, your graph's going to get wider. Anytime you have a whole number, your graph is going to get more narrow. Any questions about Perry, the parabola?
No.
Awesome. Alright, let's fill out your summary sheet. Nope. What happens when you move y equals x squared plus c? Up c, x squared minus c, x plus c squared, x minus c squared, y equals negative x squared. Very good. Inside parentheses. Okay, what does c have to be in order for it to be a vertical stretch? Greater than 1. Okay, what if a vertical compression by c, what does c have to be? Very good. But greater than 0. Because you want all those fractions. Okay, in order for it to be a horizontal compression by 1/c, because remember we always take the opposite of what's in our parentheses, what does c have to be? Greater than 1. In order for it to be a horizontal stretch by 1/c, what do you have to have? Very good. So these are always going to mirror vertical compression, horizontal stretch, vertical stretch, horizontal compression. Okay, that bottom part, for f of x equals a x minus h squared plus k, this is what we call our vertex form. And we're going to work with that more on Thursday. Okay, when we have a change in a, what happens? Vertical stretch, vertical compression, what else can happen? Very good. Reflection over what? X, because we're outside. Okay, what are our effects of H? Left and right. What about the effects of K? Up and down. That would be X. X is going to be that reflection over Y, not H. Okay, the vertex is what? Using these variables, what's our vertex at? HK. Axis of symmetry is what? Very good. Domain for quadratics? And the range depends on what? The K value. If Y is greater than K, what happens? If y is greater than k, it's going to be anything above k. If y is less than k, it would be anything below k. And this is going to be up. This would be down. Questions on our summary sheet? Okay, I'm going to hand out then your assignment. Okay, I'm going to hand out the other assignment in a second, but turn to page 3. Sorry, not page 3, number 3 on assignment. Okay, I want you to graph your parent function. So graph the parent function. If you need to make a table, make a table, but hopefully you end up having these memorized. Parent function for y equals x squared.
Can you go over the points? For the parent function.
Yep. So if you make a table, if you plug in -3, what's -3 squared? 9. -2 squared? -1 squared? 0 squared? 1 squared? 2 squared? And so on. So you're just substituting into your equation. So these are the most common points, obviously, that you're going to graph due to the size of your coordinate grid. Okay, so that is our parent function. Somebody give me a transformation that has been applied in order to get this new graph. Reflection over x. What else has happened? Left 5. What else has happened? What else has happened? Did we get more narrow or did we shrink? Narrow, so it should be a what? Vertical what? Stretch by 2. Very good. Did I write it wrong? Who said down 3? I don't even remember. What should it be? Up what? 7. So, to get your left and right, okay, compare your vertices. Vertices. Vertexes? I'm pretty sure it's vertices. 0, 0, and -5, 7. So ask yourself, what changes in x were made to get from 0 to -5? Left 5. What changes in y were made to get from 0 to 7? Up 7. Okay, so the one that people struggle with and tend to forget are those vertical stretches, compressions, and horizontal stretches and compressions. Okay, so that's why I kind of went over what I did on those notes, and even though it was small, notice the distance here is 1. The distance from here to here is 3. The distance from here to here is 5. Okay, it's staggered, 1, 3, and 5. Okay, now the distance from here to here is 2. The distance from here to here is 6. So notice 1 times 2 is 2. 3 times 2 is 6. And so on. This would be 10 from here to the next point. Okay, so that's where that vertical stretch by 2 comes from. So if I were to write this equation, y equals, okay, what would it look like? We know you have to have a negative because it's a reflection over x. Then what? How would I write this equation? How do I write the vertical stretch by 2? 2. Open my parentheses. What's in parentheses? X plus 5 squared. And what's outside of my parentheses? What goes out here? Plus 7. Okay, so that is something I wanted to do with you. I'll also hand out your other practice worksheet, but it's hard to go from the graph to the equation, especially with those vertical stretches and compressions. I'll put the answer keys up here on the board so that you'll have them. When you finish that worksheet, you can either pick up the next one, or do you guys just want me to hand it out now?
Hand it out now.
Okay, so you have 2 worksheets then to work on, so plenty of things to do.